Today I want to discuss two algebra problems that appeared in CMI 2019 entrance exam. So looking at these two problems, it really feels like we have to do a lot of tedious calculations to solve this question. But actually it isn't. They are very simple tools, like using these two problems become really easy. And it's easy to compute. So the first question says, we have to find all 2090's roots of unity such that they satisfy mod of omega plus 1 should be greater than or equal to root over 2 plus root 2. And for the second question, I have to find all real numbers x such that 8 power x plus 27 to the power x divided by 12 power x plus 18 power x should be 7 by 6. So let's do this out.
This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
See, for the first question, I know that all roots of z power n minus 1 looks like cos 2k pi m by n plus I sin 2k pi by n. And my k runs from 0 to n minus 1. So from here we can say that roots of z to the power 2019 minus 1 are equal to 0. Equal to 0 looks like cos 2 pi k by 2019 plus I sin 2 pi k by 2019 for some k. So we need to find those among them who satisfy mod of omega plus 1 greater than or equal to root over 2 plus root 2. Say for some k, call this omega. So what is mod of 1 plus omega whole square? That is cos 2k pi by 2019 plus 1 whole square plus sin square 2 pi k by 2019. And this is same as 2 plus 2 cos 2 pi k by 2019. Now we have this thing like mod of 1 plus omega is greater than or equal to root over 2 plus root 2 if and only if their corresponding whole square satisfy the same property. If and only if mod of 1 plus omega whole square greater than or equal to 2 plus root 2. That means if and only if we have 2 plus 2 cos 2 pi k by 2009 greater than or equal to 2 plus root 2. And 2's are cancelled out. So this holds if and only if. This is an important condition that 2 cos 2 pi k by 2009 this should be greater than or equal to root 2. This is if and only if cos 2 pi k by 2019 greater than or equal to 1 by root 2. And from elementary trigonometry we all know that cos theta greater than or equal to 1 by root 2, that is cos pi by 4. If and only if theta lies between minus pi by 4 and pi by 4. I dot, which is same as if and only if mod theta less than or equal to pi by 4. So using this cos 2 pi k by 2019 greater than or equal to 1 by root 2 if and only if mod of 2 pi k by 2019 this should be less than or equal to pi by 4. And this holds if and only if k less than or equal to 2019 by 8, and that is approximately 252 point something. So this holds if and only if, sorry, this is not k, this is mod k. So if and only if mod k less than or equal to 252. Now how many integers k are there such that mod k is less than or equal to 250? We have to find that. And that is also very easy. See, this is 0, this is minus 1, this is plus 1, and up to here is somehow I have 252 and somehow here I have minus 252. So between 1 and 252 there are 252 integers. Between minus 1 and minus 252 there are also 252 integers. So counting 0 we have to count plus 1. So answer should be 252 into 2 plus 1, that is 505. So this many case satisfy among 2019 many roots of unity, only 505 many satisfies mod of 1 plus omega greater than or equal to root over 2 plus root. So this solves the first question. Now what do we have for the second question? We have to find all real number sets such that this thing holds. Now see, the powers are the numbers, the bases are very they are 8, 27, 12 and 8. They are very well related to each other, both are multiples of 2 and 3. So if I substitute 2 to the power x equal to something and 3 to the power x equal to another thing, then this will give me a very simple relation. What should be this expression? We will have 8 power x is a cube, 27 power x is b cube by a square b plus ab square should be 7 by 6. And now we have to this is simple algebraic calculation. If I know leave 6 into a cube plus b cube equal to 7ab times a plus b. Now we know how to express a cube plus b cube as ab, a plus b and a plus b. So this is 6 into a plus b whole cube. A cube plus b cube is a plus b whole cube minus 3ab into a plus b. So this is minus 18ab into a plus b equal to 7ab times a plus b. Into a plus b whole cube equal to 25ab into a plus b. You already know that a plus b is not 0 because a is a power of 2, b is a power of 2. So they are all positive quantities. So we can cancel out a plus b. So if I now leave 6 into a plus b whole square equal to 25ab, which holds if I now leave 6x square minus 13ab plus 6b square equal to 0. Now we have to just solve only this equation. Now this equation is actually very easy to solve. So we can factor it out 6x square minus 13ab plus 6b square. This is same as 6x square minus 9ab minus 4ab plus 6b square. And you can just factor it 3a, 2a minus 3b minus 2a, this is minus 2b minus 2b into 2a minus 3b. So this is 3a minus 2b into 2a minus 3b. So we have 3a minus 2b into 2a minus 3b equal to 0. So at least one of them must be 0. So if we have 3a equal to 2b, that would imply 3 times 2 power x equal to 2 times 3 power y. 3 power x. So we have 2 by 3 whole to the power x minus 1 equal to 1. And anything non-identities to the power something is 1 implies that something must be 0. So this holds if and only if, this is all if and only if conditions. X minus 1 equal to 0 if and only if x equal to 1. Similarly, 2 equal to 3b holds if and only if 2 times 2 to the power x plus 1 equal to 3 to the power x plus 1. So 2/3 whole to the power x plus 1 equal to 1 if and only if x equal to minus 1. So answer should be x should be either plus 1 or minus 1. And this completes this solution.
Chinta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit chinta.com.